parallelism. There are a number of ways of achieving parallelism in NIM. You need to enable threads at compile time as follows. Ooh, we actually need to enable it. So this is needed for all the different ways shown below. So threads, we have procedure, say hi, number, and this is a thread. Okay, it's marked as a thread. Echo, hi from, and we give it the number. This was simply to make it string. And then we create threads, and we make an array of 10 threads. And each thread, so this is a new type, thread, an integer is, I guess, the number we give it, the parameter. And then for I in threads.low to threads.high. Okay, so we basically iterate over all threads. Do we even need to do that? I wonder if we can skip this whole range thing and just give it threads. Oh no, this way we're just getting indexes. Okay, I forgot. This just gives us indexes. So we do create a thread and we give it that thread I created here. Say hi, which is the actual implementation of a thread. And I is that number that we need to inject, that this is expecting. And at the end, we basically do join threads to wait for all of them to be finished. I guess we can check if a specific thread is finished or not. It is recommended that functions used with threads be marked using the thread pragma. Okay, there's a link to threads thread pragma. Let's check it out. Thread pragma. The proc that is executed as a new thread of execution should be marked by the thread pragma for reasons of readability. Okay, so purely for readability. The compiler checks for violations of no heap sharing restriction. This restriction implies that it is invalid to construct data structure that consists of memory allocated from different, thread local heaps. A thread proc can be passed to create thread or spawn. So I guess we just mark it as thread. This way it's easy to read and possibly, especially in the future, compiler might just utilize it as the language evolves. So let's run it and see if it actually runs. We replace all we have here, we save it, it's all good. If we do this with threads and add the flag run, bam, there we go. 0, 1, 2, 4, 5, 3, 6, 7, 8, 9. Okay, so we already got some inconsistency here, which is awesome. That means it all was running different threads. But what happens if I'm going to do threads off and run it? Bam, undeclared identifier, thread. So this just makes it so the compiler doesn't even know there is such thing. Okay, so during compilation, it enables some things. What if I'll just remove it completely? The default value. Okay, default value has threads enabled. Look at that. So we don't need that damn threads on. Okay, yeah, this is good enough. Cool. So I wonder if we can get something else out of those threads. Let's just look at it quickly. So we create those threads. Let's say that the let first thread is threads 0, okay? And that's a thread. So first thread dot. And we have core, create thread, data, and a field pairs, whatever those things are. We can wait for the thread, specific thread, to get back to here. Join threads, pin to CPU, okay? And running will just return bool. So if this thing is running, then we're gonna say echo thread 0 is running, else echo thread 0 has finished. Okay, let's copy that a few times and let's see what happens. When we run it, oh, error, copy is not available for type thread. Requires copy because it is not the last read of thread 0. Huh? Okay, so we started with threads. I guess the only way to check a thread is running. We need to wait for it. Create thread doesn't return anything. Too bad. Let's ask AI. Let's copy it, paste it, and see what happens if we ask AI. I expect we're gonna get some gibberish, but maybe it's gonna work. I'm working on the following NIM language code. The problem is that I can't check if the thread is running that way. The error I'm getting is, and let's give it an error. Okay, the number 9, so that was here. Let's give it the whole thing. Why not? Because the error happened at this line where we tried to do let and get error. So let's see what we're gonna get as an answer. So it indicates that the copy operation is not available for the thread type. And it requires copy because thread 0 is not the last read of that element. In NIM, whether when you access an element of an array and assign it to a variable, it creates an implicit copy of that statement. However, the thread type does not have copy operation defined, which is causing the error. To fix that, you can use the address operator to get a reference to the thread instead of creating copy. Use the corrected code. So we have the same thing, those threads. Yep, create, call them and everything. That's our code, really? Yeah. And then and this is address of that. I wonder if that's gonna work, because previously we tried that random address thing and it didn't work. Now it's here, and here we dereference it. Okay, and now we're probably unhappy about dereferencing. So let's try it. Oh, that worked. And wow, they're instantly finished before anything happens. So let's do some extra work for those, because they are pretty fast. Let's run it, and look at that. It works. We start our threads here. We have high from 0, few from 5, 2, more 5s, more 2, more 5s. I guess it's done 5s, 3, 8, 6, 8. Bunch of 2s, bunch of 8s. So basically the CPU is managing switching from between those threads however it likes. It got to 7, and here it says, hey, 0 is running. So we know that it's running. And then we have a bunch more, and 9, and 1, and then it completed the zeros. Then we finish. So if we're gonna repeat our check if it's running or not a few more times, maybe we'll see something more interesting. Okay. So here, I guess it completed thread 0 straight away. So it's finished already. But if I'm going to run it again, same situation again, same situation again. Oof, it's getting faster at finishing them. Ay. Oh, well here, also look how they're all clamped together. That means that those threads are running here. Like it's 4, 2, 4, 2, 3, 4. It runs around those. Then I guess switch to 6 and 0. And runs around them, then switch to the main thread for a moment, and bam, it's doing that. So it's running. Very, very interesting. And the thing to note here is also that, all those threads, they're trying to write to the same output. And because of that, whenever they do echo something, I believe they need to synchronize to some extent that, hey, now it's my time to write, now it's somebody else's time to write. So, this isn't that easy to really figure out. But hey, we did check the thing while it's running, so that's fun. Okay, so we did stuff with threads. Now let's move to spawn using threadpool. Instead of using threads directly, you can use the higher level abstraction provided by standard threadpool. Import threadpool, okay? And we have procedure high, which also is defined as a thread. Same thing here. And we can do basically for I and 0 to 9, we can spawn. So we can basically take our, say, high and spawn from it, right? We spawn, and this is, let's check it. I wonder if this spawn is a procedure or something else. Note, however, that spawn comes with a number of conditions documented here. So we're gonna check it out in a second. So let's see. Spawn is just a procedure. Awesome. So that means that, it's simply something like this, right? It's also interesting how we're executing it here. So the spawn, come on, show me the documentation. Oh no, it's not showing it. Oh, I think I know why. So this spawn is a procedure and text call, which is sync typed. This is very interesting. I wonder if we can do something like this. Save. Nope, we can't. Going ahead of me. So this works well. What about this? Does this work? Can I run it? Yes, I can run it. So that works. Okay. It's just very interesting to see that we're kind of executing the method here, but because this whole spawn thing, the problem here is nimble package, malebolgia, taskpool, or weave instead. Threadpool is deprecated. Look at that. So I guess we're learning about something that's been already deprecated. So let's see if in the docs here that were provided, if we have a little bit information about it. Parallel spawn. Okay, now it has 2 flavors. Spawn statement. Yes, threadpool, but there's no info that is deprecated. It's restricted, must be GC save, must be a call expression, and all that stuff. Interesting that it's not marked as deprecated while the whole thing is telling us that it's deprecated. Okay, but at least here the deprecation message gives us some packages. Malebolgia or taskpools or weave. Very interesting. I guess we can try to search for it quickly. And that's considered NIM experimental features. So we should be able to go to, again, nimlang.org. And when we go to documentation, there should be nimble package directory. And we'll put in malebolgia. Creates new spawns, experiments with thread pools and related APIs. Okay, I'll zoom it in a little bit. Okay, ideas, goals, features, less than 300 lines. Okay, we have example. Okay, and this will be probably very similar. New sequence, create master. Okay, can synchronize, await all, and we create them here. Master.spawn. Okay, so we basically have, I guess, malebolgia provides a method or procedure create master. So master object for task coordination. And we need to pass that object around. So we don't have like a default thread pool. We just need to say, hey, this is our thread pool. And we call things like await all and all things on this thread pool of threads. So I like it, although this seems a little bit, I know, limiting, unless we can actually create multiple masters, or maybe there's something like, you know, create a separate little thread pool that takes from the master. Because what if you have multiple threads that want to have their own little thread pools? I'm just thinking ahead of time. I probably would never write something like that, but hey, I've got ideas. Jan Akali sees that malebolgia is made by the language creator. It's probably the simplest abstraction of 3 of these threading libraries. Okay, that explains this quote here on top, because in many places in the documentation of the NIM language, we have some kind of quote in the beginning. So that's his characteristic of writing, so that's cool. So let's take a look at those 2 other libraries quickly. Taskpools. Okay, we can go to our package directory, put in taskpools. Okay, lightweight, energy efficient, easily auditable thread pool. Okay, taskpools will be used in a high security blockchain application. Okay, I won't read it. I just want to look at an example. Okay, so we can get those taskpools. We have some kind of procedure that does some kind of calculation. We don't need any thread markers here, I presume. We have pi approximation. Okay, pi approximation, pending futures. Okay, so this, I guess, implements the idea of future. New sequence of low-var and float. Okay, and for all those number of those pending futures, n. Oh, we just, I guess, say how many. We do, hey, spawn it from the task pool. And term k, I guess we also provided with termination, schedule a task on the thread pool and return a handle to retrieve the result. Okay, so I guess we only spawn it and retrieves it, and we can spawn some termination, something, I don't know, canceling token, something of that sort, I presume. Okay, and then for zero lengths, we just add those results together and we basically wait for each one of them. Block until a result is available. So the thing is that we create them all at the same time, but then we're waiting on them one by one. That's what I would presume, because it's not like the magic wait for all. It just does it one after another, after the other. So if we had a situation where we had 10 of those threads, we start them all at the same time. If the 10th one finished, then the 9th one, and blah, 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 but all the other threads finished, but we haven't finished the first one yet, we'll be waiting, this whole time. But at the same time, it doesn't matter, because at the end, we still need to add them up. So I guess, who cares? Unless we would have some more calculation that we want to do in the meantime while we're waiting on them. So I'm sure there's some methods for that. So in the main procedure, we basically say that we want 10,000. We do the count processors. I presume that's from CPU info. We count number of processors. We want that many threads. Okay, and we create new task pool. And here we manage default to the number of hardware threads. I guess it basically will default to that value. And then we can basically call this whole format float. And then we call the pi approximation. Yeah, thread pool pi approximation. So we call pi approximation. We give it the thread pool and the number of, I don't know, is it probably floating point decimal numbers or something, decimal digits. And then we do sync all. Block until all pending tasks are processed. And this is implied also in TP shutdown, but it would be nice to call that and then that. Okay, I get it. This is interesting, and there's more like sync all, shutdown, spawn, and a bunch of other stuff. Okay, this is definitely less lightweight than the first one. So let's just take a peek at the other one, the third one, weave. I like the name of it. It suggests threads and suggests that they are easy to manage. Let's see. State-of-the-art multi-threaded runtime. Call themselves runtime and state-of-the-art. Okay. Either from the same author. No, mratsim. Well, the other one was probably from the creator, so we just try to imitate it. Okay. Continuously tested on Linux and with both backends, compute bound, memory bound, load balancing, etc., etc. And we get some of the API here. So get the calculation of the Fibonacci. Result is sync something. So because we've has So we're calculating Fibonacci where we spawn each, like instead of recursive normal calculation, we actually delegate it to a separate thread while we're calculating something else in the meantime. Okay, I see. And then we're just doing those two kind of in parallel, and we just wait for one of them to finish. Okay, and then we have this whole thing where we just initialize weave and call the Fibonacci and exit. Okay, I like it. This is real simple, but again, there's probably a lot more to it that we could do. And this example just begs for async await, which I presume we're going to learn in a short moment. Yanakali says, taskpools is made by... So we went through threads and using the thread pool, which is deprecated. But hey, compiler will notify us about potential alternatives. Other options. You can also use the following. The experimental parallel statement. Oh, that sounds fun. And return data from spawn calls. Okay, details for both can be found in the experimental modules manual page. I won't go there now because, we're just starting out. We're not doing very parallel stuff yet.